don't you think even within narrow AI, an algorithm that looks at historic sets of inputs and outputs, and decides to understand that what features contributed to what and what is the kind of shape of the output, and then giving you that particular output, isn't that in a narrow set of way exactly doing that, but just with some human telling it what to do? I mean, isn't that also part of the spectrum?
No. I mean, first of all, they don't understand anything. These systems don't understand anything. So I think abusing the word understanding. Well, actually, I wrote an article called Understanding, where, there's a very shallow way you could say a system understands. And if you say, for example, Alexa, close the blinds, and Alexa does the right thing, then in a very shallow level, you can say Alexa understood. Yeah. But that's only in terms of that whatever your utterance, the sound waves you put into the microphone triggered
the routine,
to close the blinds thing.
Exactly.
But you couldn't ask Alexa anything about blinds or closing or understanding. So it's an extremely shallow interpretation of the word understanding. Which is the first level, obviously, is to say, do you react properly to whatever input you get, understanding? But there's no deep understanding. There is no reasoning. And also the way the system learns, it doesn't learn interactively in the real world. There are massive amounts of data that you basically number crunch, you have back propagation, and you show a child a single picture of a giraffe. They've never seen a giraffe before. The child will be able to recognize a giraffe in different colors, upside down, and baby giraffe and so on, without any difficulty. So that is, there are a couple of, one of the starting points, I think, in building intelligent systems is to say, what are the core requirements of intelligence? And again, I have an article on that, and you can list them and say, human-like intelligence. You need to be able to learn immediately, interactively, one-shot learning, zero-shot learning, thinking about it. And you need to be able to do that with limited resources in a noisy environment. So you need to be able to disambiguate or ask for clarification, so there could be contradictory information. It might be incomplete. It might be wrong information. You need to be able to take that in and then say, well, this contradicts something I already know, or I'm missing some piece of information. And you can't put that into a number crunching type of thing that runs for 48 hours and uses electricity of Manhattan volume of electricity to learn something. Okay, I'm exaggerating, but still, intelligence requires a couple of things like that: the ability to learn, the ability to understand something deeply, and the ability to reason about things. And I think it's generally accepted that deep learning, machine learning systems do not have the ability to reason. And that sort of, but they also don't learn interactively and know what they're learning.
Fine, that's great. Actually, so on that topic, Peter, explore that a little bit more on the why. Why do we need machines that can understand? Right? What's the holy grail there? Are we trying to? I mean, is it a desirable thing to create things that are more human-like in the way they understand the world and perform actions? Explore that for me a little bit. Why is AGI? Why understanding machines